Hello class, this is a video tutorial on binomial distributions and probability part 2. In this video, we'll be looking at applying the formula for binomial probability. So given an event, X is definitely a Bernoulli trial, and we know that the probability of one success is some fraction or decimal p. In order to calculate the number of successes, which we've labeled R, with n repetitions, we simply use this formula. Now, it may seem a little cumbersome at first, but I'll demonstrate to you using these 4 examples how we might apply this formula. You can go ahead, pause the video, and give this a go yourself. Okay, so let's get straight to it. So we're going to calculate the probability for each event. So let's pull this up actually so we can utilize it. Okay, so in this one we have a regular coin toss or coin flip, and the number of repetitions is 10. Okay, what we are looking for is there being 4 successes. So before we begin, we should actually define our Bernoulli trial or our binomial distribution. So we say that in this case, X follows a binomial distribution where we have n repetitions, so it's 10 repetitions, and the probability of success for one success, well, since it's a regular coin and we're looking for heads on the coin, the probability is 0.5, or the equivalent fraction if you'd like. Now from here, we are calculating the probability of P X. So X is this binomial distribution. How many successes do we want? Well, in this case, it says 4. So 4. So for this, it's going to be, following the formula now, it's going to be n choose R. So n choose R. P, which is the probability, and for this I like to use lots of brackets, 0.5 to the power of the number of successes we want. So in this case, it's going to be 4 successes times, now 1 minus p, you can think of this as the probability of failure, because if p is the probability of success, 1 minus the probability of success is the failure. In this case, it's still also going to be 0.5 to the power of n minus r, so 10 minus 4 is going to be 6. One of the things you can always take a look to make sure that you're doing this right is these should always add up to the number of times we ran this, we repeated this trial. So if you type all of that into your calculator, I've already pre-prepared it here. I'll give you a moment to type it in. You should get 105 over 512, or the equivalent decimal approximation for that. Okay, so hope you can see that by using this one example, we can define our binomial distribution or probability and then apply the formula. Okay, let's do the next one. So we have a regular die is rolled 10 times. Okay, so we can say that X follows a binomial distribution. The number of repetitions, once again, is repeated 10 times, so 10. The probability of the results being a multiple of 3 6 times. So 6 times is actually not needed for this portion yet. 6 times is the number of repetitions, but the probability of success is multiples of 3 on a regular die. The only numbers I can think of are 3 and 6. So the probability of success for 3 or 6 on a dice is 2 out of 6, which I'm going to simplify as 1/3. So that is our binomial distribution. Now applying our formula, P of x equals 6 successes is equal to n choose r, so 10 choose 6 successes. The probability of success is 1/3, following this, to the power of the number of successes. And now the probability of failure, so 1 minus 1/3, is going to be 2/3. And remember, the easiest way to figure out what this will be is that these two numbers should add up to 10. So 6 plus 4 gives us the 10. And once again, I'll give you a moment to type all of this into your calculator. The answer you should get for this is this fraction here, or the equivalent decimal. Okay. Hope you're starting to see that it's not too difficult. In the next video, because this is starting to get pretty long, in our next example, this one, I'll demonstrate to you a unique way in which we can apply this formula. So here's our last example. So we have a bag containing 5 blue, 3 red, and 2 yellow, and a ball is randomly drawn from the bag and then put back. If this is repeated 15 times, calculate the probability that yellow appears 5 times. Okay, so first we should define a binomial distribution, or binomial probability. N is the number of repetitions, so we are repeating this 15 times. And the probability of success is, well, because we're looking at yellow, what is the probability that yellow is drawn from this sample space? Well, in total there are 10 balls, and 2 of them are yellow. So 2 in 10, which is 1 in 5. So that there is our binomial probability. And now we're simply applying our formula, this one here. So probability of x equals the number of successes is 5. And that's going to be 15, choose 5. Probability of success is 1 in 5 to the power of 5. The probability of failure is 4 in 5 to the power of, the sum here should be 15. So to the power of 10. Now, once again, giving you a moment to type all of that into your calculator, you should get, now, this time, if you take a look, my calculator actually wouldn't show it as a fraction. So this is the approximate decimal value that I got. 0.103182. You can round that off to whatever number of decimal places that you would like. Okay, so hope that gives you an outline and overview of the basic applications of binomial probability. I'll see you in the next video where we tackle a slightly different way of doing it. Hope to see you then, and best of luck.